The following content has been provided by RWTH Aachen University.
All right. Good morning, everybody, and welcome to Designing Interactive Systems 1. So today we're going to continue our discussion of the history and the sort of big steps forward that HCI has taken over the years and decades. In the second part of this really short review, we're going to take a look at Windows, Microsoft Windows, and then we are going to have a little topic on how technology evolves over different phases. And after that, we will take a look at some sort of visions from the past and how those how they saw the future, because that is kind of not just highly entertaining occasionally, but also informative to see what people were expecting, because that gives you an idea of when we imagine the future today. We're not going to get everything right, of course, right? And it's informative to see how people have guessed wrong and what they've guessed wrong, because that can help you maybe make better estimates on how things are going to be evolving from today into today's future. So, and before we do that, quick review. We talked about different dimensions of user interfaces. This was the Jacob Nielsen sort of classification of UIs according to 0D, 1D, and then we talked about 2.5D user interfaces. Would anybody care to sort of try to summarize in your own words, really sort of roughly what those dimensions mean? I know that's a tough one this early in the morning. Turn on your brain and all that. And it's even better if nobody raises their hand, because then I can just pick somebody, which is awesome. I'm going to start with Felix. How about you, Felix Roos?
Yeah. Okay, I think 0D at the very beginning was when you just like give a batch job to the computer and then like wait for hours and days to get the final printout from the computer back.
Mm-hmm.
Then 1D, I imagine, is like some kind of command line interface. You like write
Mm-hmm.
something, press, and then get a result within like a few minutes, I would say. 2D is like our typical computer, and 2.5D was, I think, when overlapping windows were introduced.
Yes. Exactly. Yeah. Thank you, Felix. That's right. One minor addition, maybe the 0D and 1D interface. So first of all, the 1D interface is command line interface. You'd actually be getting a response typically within a fraction of seconds or seconds, not minutes, hopefully, most of the time. But the point of the dimensionality is interesting. If you look at it from sort of a pseudo-mathematical standpoint, the 0D was called that way because there were only very discrete points in time, and a point is a zero-dimensional graphical object, of course, in vector mathematics and linear algebra. So a zero-dimensional thing is a point, and that's a point in time where you interact. It's like, you dump off your punch cards at, the operator's desk, and then there's another point in time much later where you interact. Whereas in the 1D interaction of the command line, you have basically an ongoing line of bits going down the serial line and traveling back. That's the idea of why this is sort of one-dimensional, like a line of interaction. And then 2D is much more obvious, as you said, the full screen interface, typically something that people then associate with graphical user interfaces. Although even with a text-based user interface, you can have a full screen text editor, for example, where you can move your cursor around, X, Y coordinates and interact with the system that way. So it's a little bit of a artificial comparison, but it maybe helps to remember that these were qualitative differences in how it felt to interact with them. And you were right about the overlapping windows that kind of stacks things into almost sort of a third dimension, but of course not freely. This is not talking about 3D interfaces just yet. That will be coming with AR and VR, actually. So maybe, if we asked Nielsen today, he would add maybe 3D user interfaces then as that next step. Right. And then we've got HCI innovations and a couple of these key things. So first of all, Sketchpad. If you had to name, one or two things that you thought were really sort of, that where Sketchpad broke new ground. And just for orientation, everybody, we're in the 60s, right? So what was new in Sketchpad that people hadn't seen before?
So it was the earliest example of a sort of touchscreen interface. Proto touchscreen interface. It is similar to how we use styluses today. So
yeah, so we were using a stylus. This was called a light pen back then. Check out the PhD thesis from Ivan Sutherland. Actually, it's fascinating reading. It actually has an instruction on how to build a light pen that works, with a cathode ray tube, old style oscilloscope or TV or monitor. So yes, the stylus, the graphical interaction with it was new. And there was, of course, drawing in 3D. There was rendering objects. There were hidden lines, even if you think about it. Later on, they moved from 2D construction to 3D construction with hidden lines removal and all that kind of stuff. And actually, even when you look at the very last part of it, there was another kind of interaction. Do you remember, Shailesh, what they were doing towards the end of that video demo?
So they were using, I think, dedicated keys to switch between functions.
Yes, yeah. So that's right. They had dedicated function keys. How he's like tickle that toggle, as he put it, to change things. And Frederick, there was something else towards the end of the demo. Yeah, go ahead.
Yes, they showed 3D editing, which for me seems to be completely new for a computer interface in the 60s.
Absolutely. So the 3D editing was definitely new. And I'm talking about even later in the video. That's something that people often forget because it's kind of tacked on as a demo. Felix, do you have an idea?
I think they had some kind of speech and handwriting recognition.
So they wish they had. The very last sentence is like, we're going to look at, speech and handwriting. And I love this. Like, here's this research in the 60s. He's just discovered the graphical user interface. He's like, yeah, I guess next week we're going to do the speech thing, and then maybe the week after we're going to recognize handwriting. Completely, of course, underestimating how difficult that is. But also very visionary, immediately already thinking about like how else could you interact with the machine, with a computer. Still haven't quite nailed that last example in the video though. Shailesh, any ideas?
Was it the fact that they had an infinite sheet of screen essentially that they could move across, etc.? Earlier, it used to be limited screen interfaces.
So that was an interesting new thing, that the infinite zooming in and out that they described, how they could store things in a sort of a vector format, so they could zoom in and out arbitrarily. And change the zoom factor of the display. But I'm actually talking about the last part where they actually, if you go back and look at that video again, they do flow programming. They actually define graphically a flow chart, you would call it, in programming, which was kind of the way, you would write programs back in the day, or conceptualize programs. Today you might draw, class diagrams and use some kind of, notation like that. But the example there was a flowchart that they actually created graphically on the screen and said, and this is something how a programmer could write code, which I think is really interesting. That's like a graphical programming environment, essentially, that they were, at least thinking about. They're not demoing it very much in the video, but it's being shown briefly. All right, so moving on to the NLS. What do we have there? Doug Engelbart, mother of all demos. János.
So it had the there's a ton of things, but they had multiple windows that you could use to edit. They had the mouse, which was just like crazy. They had I think collaboration in terms of editing, that you could do stuff. They had I don't know if it would technically be called object oriented, but you could like link to things, and they had this kind of object structure within the lists of like how you can describe things and like subcategorize things. I think those were all new to the NLS.
Great list. Thank you, János. The mouse, of course, sort of being the poster child of that demonstration, because that is something that totally stuck, and that basically every desktop computer then for the next 50 years would be featuring. which is amazing. But you're right about the word processing, the hierarchical document editing, you know, with these basically like a fold-in hierarchical text editor, right? That you saw there with this shopping list of oranges and apples and stuff. And the collaboration using video conferencing and two mouse pointers on the same screen, which also then kind of like disappeared from the face of the earth for the next 30 years until we finally got some collaborative editing tools in sort of the 2000s. There's one more thing that you may remember. Apart from the mouse, there was another unusual input device that we actually saw resurface again with the Alto and Star. Johannes.
The chord keyboard.
Yes, exactly. So the chord and keyboard, multiple keys. You need to press multiple keys at once to create a chord, kind of like on a piano keyboard, and that would then generate all sorts of letters or even shortcuts, macros, etc. And that was one way where you could, with one hand and 5 keys only, you could enter the entire alphabet and more. As you can easily figure out, you got 5 keys, so you got 2 to the 5, 32 different options of combinations that you could technically enter in this. Right, so moving on, that was still in the 60s, right? 68 was the demo, and the mouse was even a couple of years older than that. So now we're moving on to the Alto. We're entering the 70s. And apart from, hippies and free love, the Alto came out. So what was new with the Alto? And maybe the Star. We can roll those two into one because they were basically following each other. There was quite a distance, almost 8 years, but they kind of built on each other, and they're sometimes a little hard to tell apart. Johannes.
Yeah, they had a graphical user interface instead of a textual one. Mm-hmm. And you could drag objects around, and they had similar actions, so you could drag documents into folders. So to change where they were located, and you could drag them onto printers, so they would be printed and so on.
Yeah, that's right. So here basically the big difference is, I think, if you sat down at NLS today and nobody gave you any instructions, well, first of all, you would be completely flummoxed by the chording keyword. But put that aside, you would struggle quite a bit to recognize interaction patterns, design patterns in the interface for what you know from Windows 10 or something. If you sat down at an Alto, you would not feel totally out of place, right? You've got some icons that you would know you need to double click to open, and you drag them around. Some things are going to be different, right? These dedicated function keys, for example, that the Alto had with move, copy, and delete, and those kinds of things, or properties. This is different from what we do today, but a lot has changed surprisingly little. And Shalish, anything you want to add?
Yeah, so they also had an early version control system for documents.
Yeah. So you would save things. So the version control really came into place. I think with the Lisa, we saw that where we compared it to the 2011 feature of Apple, where you never had to save again because it was automatically saving all the time, and you would only save when you wanted a named state that you need to be able to explicitly.
And also, I think they were the first ones to do WYSIWYG, essentially. What you see is what you get, editing.
Yes. So WYSIWYG, absolutely. The WYSIWYG editor, Shirley, you're right. That's a big part of the demo, especially from the Star, where they talk at length about how you format a formula and you italicize it and you boldface it and you change the indentation. So what should surprise you is that, especially the Star demo, where he talks you through the desktop, it's surprisingly boring because we know this stuff from today. Like he says, oh, and this, we call this an icon, and you're like, yeah, of course this is an icon. But remember, this guy they were making stuff up, right? They were inventing the icon at that time, and they were looking for words to give to these new concepts. And so I find this sort of strangely exciting to see people, just discovering this kind of stuff and inventing it there. So then the big difference, of course, is a bitmap display here compared to the text one. We already said that. And that enables the GUI, right? The graphical user interface. You can't really do that if you only have letters to work with on your screen. Janos before said that NLS had this sort of object-oriented thing. I guess the most precise term you could use for that is sort of hyperlinks, right? So hyperlinked objects or text parts where you could go from one part to the next. That was the big thing there. Okay, so and then we do get to the Lisa. We're now in the 80s, right? The star was already 81, so what was new with the Lisa? Janos, go ahead.
So I know we mentioned that they had the like menu bar on top to access functions in a nicer way. And then as well, the thing that we talked about with the saving that then ended up being replicated in Lion as well.
Yeah.
I think those are both innovations.
Yeah, and maybe we can. You're right. Those were this was the first bitmap computer, GUI computer Apple made. It wasn't quite successful because it was very slow. And then the Mac came around, and what did that introduce? It just took them basically a year or so longer to release. Key innovations of the Apple Macintosh then. That was towards the end of the class last week. Johannes.
Was it that one could write own programs for the Macintosh?
Yes. I'm not sure how that was for the Lisa, to be honest. I think you could write applications for the Lisa, but for the Mac, especially in difference to the Alto and Star, who were supposed to be document processing systems and were kind of a closed ecosystem. Yes, the Mac definitely encouraged developers, third-party developers, to write software for the platform, and went out and wrote these human interface guidelines that created the first sort of consistent look and feel for a graphical UI, and then also sort of evangelized people, developers, and told them how on earth you write a program for something that uses a mouse, right? Because no developer out there had ever seen that kind of stuff. They'd never used those systems, and certainly not written code for them. So nobody knew how to do that, and that was sort of being taught. Literally, Apple educated its developer base to write graphical user interface programs. Andreas.
Yeah, I think one of the advances was also that it was made for hobbyists, so it was more widespread and also somewhat more affordable than the Lisa, so it was more of a success.
Right. That was a big one. So it was cheaper and it was faster because they re-implemented a lot of the stuff that had been done in Smalltalk in sort of back in the day, Pascal, I believe, and assembler, of course. For the low-level routines, to actually enable this system to run fast enough so that you wouldn't have to wait forever. Shailesh?
Yeah, so they had two key innovations with respect to input devices. One was that they, instead of having a chord key or dedicated keys for copying and pasting and other special functions, they started to combine keys into hotkeys so that you could do, for example, to copy, you could say Command C, and to paste, you could say Command V. And they had an improved version of the mouse, which only had a one button thing. And
very much like sort of Engelbart's very first wooden prototype that I held in my hands at one point. Yeah, that was, and of course, Apple's always been known for trying to reduce to the max, kind of, right? So really make things as simple as humanly possible to really take down the barriers to entry, and at the cost, of course, of some sort of advanced high-end professional interaction sometimes. So of course you can do more things and faster with a 3-button mouse if you know how to use it, but if a 1-button mouse is just incredibly unthreatening, right? There's a button on the mouse, you press it and then stuff happens and you don't have to think about which one or be afraid you pressed the wrong one and things like that. So for the longest times there were no context menus on the Mac all the way into, I don't know, System 7 or something. Never any context menus. Those only appeared very late, and then because the mouse only had one button, there was no right click on the Mac, right? It didn't exist until much later. Okay, good. And so the fact that all the apps that were written for the Mac were extremely consistent because Apple educated its developers, the documentation strongly pushed to write consistent software user interfaces. That was kind of a first, right? Nobody had ever done that before and created this world of applications and an ecosystem in which third-party developers could thrive and develop apps that would actually feel kind of like the built-in apps. And that has stuck with the Mac, right? If you released an application that would not quit on Command Q, and where the quit command was not the last item in the first menu that you drop down, it would fail with the user base, no matter how awesome it was otherwise. The users really got spoiled, and I think rightly so, to expect things to be consistent in that way. And there was no, if anybody wrote an application that you had to quit with like Alt X4 or F4 or something, it would get scathing reviews, because that was just not how you do things on the Mac. So the consistency. Okay, and now we're going to move on to Windows, and let me start with a little ad. So you've probably heard of Steve Ballmer, one of the faces of Microsoft, and one who has never been shy of a joke. And here's a fake ad for Windows that he taped in sort of the style of a car salesperson. It's quite entertaining. So let's roll that tape here. All right, so that would be Windows. So let's look at what Windows added. So the very first version, Windows 1, which none of you have ever seen, obviously. Very few people actually saw that because it wasn't a big success. But you probably know that Bill Gates kind of like cut his teeth by writing a basic interpreter for early computers and sold his basic computer, his basic interpreter, and then that got built into the IBM, and then there was DOS being written and stuff like that. So Windows was the first graphic user interface that Microsoft did, and clearly also, just like Apple, they were inspired by what they'd seen in the Alto and the Star, right? And you can see the Star came out in 81, and Windows came out in 85. In between, we'd seen the Lisa and the Mac being released already. But the Lisa and the Mac were more inspired by the Alto, the earlier design, and Windows was a bit more inspired by the Star, shows in some design details. But it was beginning with something that would become almost a defining aspect of the Windows line of products, and which was both the great benefit that a lot of people already had IBM PCs or IBM compatible PCs with DOS on them, right? That was sort of becoming already the industry standard in small businesses, etc. So they were able to build on that user base, but how do you build on that? By making it so that it can run on top of DOS, right? Completely different from how the Apple machines work, because you bought a Macintosh, it wasn't compatible to anything, right? Okay, maybe the Lisa in some way, but there was no way to install Mac OS or something on an existing text machine and adding a graphic layer. So the Mac was this whole package. Everything came in one box: the hardware, the operating system, the GUI on top of it, the apps, at least starting the key apps. And here you've got instead Windows, which was building a graphical interface that was a separate layer that you literally, in the early versions of Windows, you had to start, right? There was a command that was called Windows or Win or something, where that would start up Windows from the DOS command. So you could see it was an additional layer on top of it. And on the one hand, the benefit is, of course, you can run on lots of existing hardware, but the problem is that it means you need to be backwards compatible. And that became something that both helped Microsoft tremendously, but also kept them tied down by having to still support sort of, DOS-based machines, and then later on, lots of older APIs. But it did bring a lot, the Alto, Star, Mac, Lisa interaction style to the huge population that existed of DOS computers, and also in some way of Unix. So actually, early versions of Microsoft Windows were released also for Unix at the time. Unix being mostly what was running on research lab machines and universities and research labs around the countries. So here you can see the GUI is sort of compared to what Apple was able to do, because they were cutting everything off cleanly and starting with a GUI from scratch, was a little more limited, right? So we have a little more clunkier view of it. In fact, Windows 1 did not allow you to overlap windows. So you can see here the MS-DOS executive and the control panel are beneath each other in a tiling arrangement. a tiling window manager, and you couldn't actually overlap them. This was not part of Windows 1. It was a quick shot trying to get a grasp on graphical interaction and get a share of the market before Apple was going to gallop away too far with its interaction. But you could use the mouse, as you can see here, and start using these menus and so on. We will talk more about Microsoft Windows actually in DIS2. So next semester, we're going to take a much closer look at the history of how that evolved. But this was sort of, when we only, in this history review here, I'm only looking at what were significant markings where stuff changed qualitatively. And this actually brought the graphical user interface to a huge population. So then we get to one other thing that you've probably not heard about, unlike Windows, but I just mentioned the Unix world, right? So the Unix world was mostly running on terminal systems, and they did have X Windows. X Windows came out in I believe 81, and this was the graphical user interface sort of toolkit for the Unix world. And on top of that, several Windows systems were designed, because X was actually more kind of like an infrastructure to write Windows systems. Very flexible. You could exchange everything in X. It's a major design feature of X Windows to this day. And so Motif was one version of an object-oriented toolkit architecture on top of X and Unix. So you got a Unix underpinning, again, a textual operating system, kind of like DOS on the Windows side. And then you got X Windows running on top of that. And also you literally launch X with a command line command or in a startup shell script to make it run. And that's how your Linux desktop works today. If you're running a Linux machine, it still does the same thing behind the scenes. And then on top of X, you would have applications running that use the X Windows system and that use a certain widget set, we call it. So a collection of designs and scroll bars and buttons and window framings and so on. And one thing that was pretty amazing for Motif was that they managed to create a programming API that was actually object-oriented. And this, although the underlying language was C. And C, as you all know, is as imperative language as you can get, right? It's one level above assembler, but just barely. And there is no object orientation in C. But the way they did this was by basically thinking object-oriented and having these, if you want, abstractly speaking, classes of, for example, a push button, and then there would be a subclass of the push button that was the toggle button or something. And even though all the procedure calls were procedural and imperative, of course, they were in C, the thinking behind it and the way that parameters were passed on and were inherited was object-oriented. So you can do object orientation without the language supporting it, but it's hard, right? And it's not super easy to program. I ended up writing a tutorial for when I was a young lad for OSF Motif called XM Tutor, and that explained how to build graphical applications with OSF Motif. It was released by the Open Software Foundation, which, guess what, was neither open nor a foundation. It was basically an industry conglomerate that was releasing that, and certainly not for free, and wasn't releasing the source code anywhere. But the name sounded nice. Again, more about that in DIS2. So now we are, here's a lineage to summarize this part of our little trip, through the history of graphical interaction, mostly on the desktop so far. That is from the year 2000, and it shows an interesting. So sorry if you can't read this. This is tiny, but I wanted to show you the whole graph in its entirety. You can take a look at it in more detail later on. I'm going to point out a few interesting paths. The first path that I think is interesting is up there. You see the Memex, right? The one that was done in the 40s. This brainchild that really just a vision of how the future could work. The Memex was never built, right? But it inspired. Then, as you can see here, Sketchpad, Ivan Sutherland system that we've seen, and NLS that we've also seen. So this is sort of the roots of the system. Another interesting route is if you take NLS and see how that continued on. NLS led directly to the Alto, which we've talked about here, and other things influenced this. And there were other projects by Sutherland, Evans Sutherland, and the Stanford AI Lab, and they ultimately then were things that Apple saw and built the Lisa and the Mac, right, as you can see further down in this connection. So that's an interesting link via the Alto. And then what you can also see is that there's the star system. You can see the star is kind of in the middle of this thing, has lots of ingoing and outgoing connections. So it was a sort of, it really combined a lot of influences in one coherent system. And it in turn influenced a lot of others. And you can see Windows inherited a lot of things from the star. In fact, some applications made it over there. I'll talk about this in a second. Another line that's interesting is on the language side. We've got Simula as a very early language that influenced Smalltalk. Simula done in the 60s, and Smalltalk being the first sort of widely used object-oriented language. This was the language that, for example, then the star and also the Alto were sort of developed in, and that also, as you can see, led to the Lisa, but not the Mac. Right, the Mac was not no longer running Smalltalk. That's what gave it its performance boost. So giving up a little bit of elegance and design for just sheer performance that was needed, because the 68K processor in there wasn't going to pull its weight otherwise. And as you can see, this led via various other languages, blah blah blah, to Java, right? So that's where Java came from. It had its like all object-oriented languages, it had its roots in Smalltalk and Simula. And maybe another one that could be interesting on the side of applications. You can see here the Alto had something called the Bravo editor, and the Bravo editor was basically a text editor, a document editor, a word processor, I would say, with styles and all that kind of stuff. And that led then to Bravo X. This was a little bit more an advanced version then, which was then further developed into, believe it or not, Microsoft Word. Word was reported to actually still have some code of the Bravo and editor inside it. Somebody told me who was actually on the team when I met them at Stanford. Here's another line that's interesting. It goes a little bit more recent, but you can see the Bravo editors then sort of leading to note-taker applications and so on, and then ultimately leading to mobile devices like the Apple Newton, which was an early sort of the first sort of handheld device that you could actually scribble on with a pen and do handwriting recognition. And that was then sort of adopted, this idea, and improved upon by Palm. The Palm Pilot was a very popular PDA, a personal digital assistant, a handheld device of the 90s that people used to take notes by scribbling on a touchscreen with a little plastic pencil. And you can see down here at the end of these lines of these developments are things like Windows and OS 10 at the time. Since this stops here in 2000, we're not seeing more recent version here in this. This is just trying to give you an idea of the early history up to this year. Okay, so now I want to take a brief moment to reflect with you on how technology evolves, because we've seen lots of examples of Windows systems and graphical interaction paradigms and so on, the mouse, these hardware innovations sort of making their way from a research lab into application. And I encourage you to draw yourself not just one, but two history lines at home. One being, what did we see here in research labs when things were first introduced? And when did we see things in wide use in industry? And you will see a shift between those two. But what often happens with technology is that it gets adopted in these phases. And I want to talk about these just for a second. So during the life cycle of a new technology, which could be anything, from the mouse to graphical editing to the cell phone or whatever, you first often have a phase where things are being developed in research labs, and where if they get out of the research lab at all, they're mainly adopted in a hobbyist phase, in an enthusiast phase, I would call it, which means it's there because the technology says exploit me, use me for doing crazy stuff, right? And it's going to be difficult. You're going to have to read lots of technical data sheets and stuff to make it work, but you can actually make this crazy thing work. Imagine this maybe as an example with the mouse, right? So the or the light pen, right? You could maybe not download back in the day, but you could borrow the PhD thesis from Ivan Sutherland, and you could build yourself a light pen, right, if you really wanted to. from there on, oftentimes technology matures, and at some point, businesses discover that, okay, this is good enough to actually save me some money, make me more productive in my work, right? So in the example of the light pen, you might say when the mouse actually entered the phase of being used in the Alto and the Star, and then ultimately the Lisa and the Mac, it actually hit the market, right? It became something that people would buy and use for offices. So for example, the Alto and Star being clear office devices for the professional, used the mouse, and it was there to help them do their work. And then you kind of see the consumer phase, which means it enters everyday life of people using it for the private hobbies and stuff like this as well. And it just becomes a part of everyday interaction. And this is not very different from the hobby phase, where you've got nerds, honestly, to who just love using this really brand new, gently smoking prototype technology, to people who just want to use the tech to make their life more enjoyable, easier, right? So this is when you would say the Mac kind of made that happen for the mouse, right? You could just go out, buy a Mac, turn it on, it would be a friendly interface, the mouse would be part of it, you would use it, draw a couple birthday cards, print them out, and send them to your friends. These three phases are often observed in technology, and the person who came up with recognizing this pattern is called David Little. Now, David Little is not an unknown person in HCI. He actually wrote the display controller software for the Alto. So he'd been around for that as long a time. And then he became, for the Star, he became the project lead. So he led the Star design project at Xerox PARC. And he's then founded a company called Metaphor and became a leader of Interval Labs, which was a think tank of the 90s, and then moved into sort of venture capitalism. And he proposed this in an article that you can find in a wonderful book called Designing Interactions by Bill Moggridge. I'll talk about that book later on. And I read this and I thought, this is very true, but it's missing one point, which is after that phase, when things have arrived at this consumer phase, oftentimes, almost always, something else happens. You reach a sweet spot where this thing is really great and it works perfectly. All the kinks have been worked out. For example, the mouse moving from a mouse ball to a laser tracking thing where you don't no longer collect all the fluff on your desktop with your little rubber mouse ball. So it becomes, zero maintenance essentially. And then something weird happens beyond that sweet spot where the device is basically fully fulfilling its original purpose. All the kinks have been ironed out. It's really convenient. You can't sell it anymore once everybody has one. So then you need to add things to it to sell more versions of it. And that's when you enter the Baroque phase, when you enter the phase of mice that have 15 buttons or that have higher and higher resolution that only for very specific use cases make sense, or that come in a million different colors, or that have glitter attached to it, or that glow in the dark, or that heat up, or to warm your hand. So this is when you enter the Baroque phase, where these things get more and more stuff. And there's mice now out there that have a display built in to do some settings on them, which is kind of funny. I'm not saying that these devices are useless, but what they're adding to it is much less revolutionary than what the original sweet spot device provided. It's more incremental, more stuff added to it. And oftentimes these things go to features beyond the original sense of the device. The mouse was there to be a precision, fast, high speed sort of input device in 2D. And beyond that, more things were added. Pascal, go ahead.
Would you say that our common smartphones right now are like this beyond the sweet spot? We added so many techniques and things we can do with it, and basically does everything at all. And do you think that's the Baroque phase at its best? Because we encounter on each and every day that our devices are capable of everything, and we actually sometimes abuse them to use them as computational power.
Yeah, just to somehow burn all those cycles that we can put into them. Hold on to that thought about the watch, the smartwatch, and specifically that you mentioned. And let's take a look at two examples that I'm going to show you. And then maybe you can pick that back up and discuss whether you think the smartwatch is, in which of these four phases do you think the smartwatch is these days? I don't want to start that discussion now. I want to show you 2 examples first to illustrate better what I mean, if that's okay. Theo, you had a comment too.
I had a question regarding the consumer. So maybe some technology isn't intended for the everyday consumer, but rather intended for like businesses with special purposes. So in that case, what is the consumer phase?
Yeah, that's a great point. This doesn't match every technology, surely. I'm looking at sort of fairly fundamental enabling technologies that get used in a lot of different products. So for example, I'll show you 2 examples. One is the cell phone, right? Where you have it getting used in business contexts, but of course also these days, mostly in personal life contexts. But there may be things where they were never intended to be used for the consumer, and sometimes they actually still become a consumer device, or somebody sees their use in consumer world for it in an adopted fashion, maybe. You know, you can buy a 3D printer at MediaMarkt and take it home and print yourself some figurines for your board game if you want. Although when people built professional grade 3D printers, they were never intended to be used by, you know, the private person. So in a way, it's certainly not the same product that enters the consumer life after the work life. It's a different product, and it needs to change in order to make that transition. And not every technology or every underlying invention has that quality. I totally agree with you. But a lot of them do, and maybe more so than we initially think. All right, Zion, go ahead.
I would also like to add that in terms of software, usually the product doesn't necessarily shift, but it can be in multiple of these phases at the same time. Like if you have like a beta version of the software or a nightly version for the enthusiasts, and standard long-term support for consumers and so on.
Yes, yeah, great observation. So you can actually see that in sort of, you know, you take, I don't know, Node.js, right? There's an LTS version, long-term support version that everybody can install, a consumer who doesn't want to fiddle around with it, but you can also go with the bleeding nightly build of the alpha and live with all the, you know, crashes, but also get all the latest features. So yes, that sort of shows that different versions of the same product can be in different phases here too. That's a good observation. Thank you. So a couple examples. This maybe will make it clearer. Let's start with GPS. Okay, so satellite navigation, right? Here's a picture. I'm in San Diego. This is 2007, I think. I'm in San Diego. I have a PDA. This is my Cyan PDA from the 90s. It's a little bit, it's not a smartphone. It's just a tiny little computer with a keyboard and a screen, right? That's all it is. You can put third-party software on it. And somebody by that time had written an application that would let you download little maps onto this PDA and would let you connect an actual GPS receiver to that PDA. Now, the GPS receiver was this little extra box that could do nothing. It had like the tiniest of displays, so you would never want to use it to actually, you know, look at a map. It could only show you the coordinates where it thought you were. But GPS, you know, in 2001, GPS was released to, you know, to be usable by the private, you know, consumers and anybody, right? Before that, it was military locked in terms of precision. You couldn't use it really well. And so by 2001, you know, GPS became a thing in the private world. And here I am in 2007, and I actually managed to set this up because I had just moved to San Diego and I didn't know the city. So I thought, I'm going to use this navigation thing, right? So I managed to set this up and plug the power cord into my car, plug the GPS receiver into my, you know, into my PDA, and then somehow perch the PDA on the dashboard of my car. And I could actually use it to navigate to a place in the city, which was unheard of, right? Nobody was doing that, right? This was clearly me being the enthusiast / nerd, just doing it for the heck of it, right? Trying to push the envelope, really trying to actually make this work. But it was not set up for anybody to just pick up and go, right? You wouldn't just buy this and plug it in and go. You'd had a lot of fiddling to do with, you know, serial adapters and whatnot, and batteries of different kinds, etc. You see lots of cables here. So this is the enthusiast phase, right? Where you only do this if you really, really, really want to. And then if you look at GPS, what happened next? Well, the next thing that happened was actually not the TomTom for everybody that you could just glue to your windscreen, right? The next thing that happened was that trucking companies discovered the use of this. People who were driving for a living, who are running a transportation business said, okay, this is complicated technology, it's expensive technology, but I can make a case if my truck fleet gets equipped with these things and we put, you know, a couple €1,000 per truck in there and make this work, it will save us so much money in the long run because people won't get lost on paper maps anymore, that it is actually a valid expense, right? So this is the professional phase of GPS use, help me work. And of course, in the case of GPS, there was a military use before, but as I said, this was a different kind of GPS that you couldn't really use as a non-military person. And only after that, we saw GPS receivers. We're now in the sort of, you know, 2010s somewhere, where companies like Magellan and Garmin started releasing these increasingly capable GPS receivers. As you can see here, this GPS receiver still is clunky and big and has this antenna sticking out, but it actually has a map, right? This has a map right on the display. So this you could maybe buy as a hiker, as a hitchhiker, and just, you know, walk through the woods with this and not get lost in the wilderness, right? This was what this was intended for. And it became, as you can see, very different from the top photo there. It's one box, you put in batteries, you turn it on, and it essentially just works, right? This is the consumer phase. Enjoy me, right? Use me without having to fiddle around with technology too much. And you might say, well, this isn't quite ideal yet from a usability point of view, right? And I would argue that sort of the first sweet spot that GPS really reached, where everybody could use it and it was super easy and changed people's life. Because honestly, the walk, you know, the GPS on the left here that you use to hike through the wilderness won't be of much use if you're driving in the car, right? Because you can't always look at it. It's not mountable and the display is too small and not bright enough to look at while you're driving and all these kinds of things. And plus, it wasn't giving you walking or driving directions. This was just showing you a map and your directions, right? You just could see, I'm here on the map, and this is where this is where my next waypoint is, basically, right? This was not turn by turn. Well, this was actually turn by turn directions in the first version, if you look at the screen closely. But the sweet spot for this was this kind of thing, right? Your TomTom, as we used to call them for a long time, a GPS that you go to, you know, your local electronic shop, or you go on Amazon, you buy it, you unpack it, it's already pre-charged, you stick it to your windshield and go, right? That is, to me, the sweet spot, because that fundamentally changed and impacted almost society as a whole, right? As soon as people started getting these things, they started driving completely differently. They started relying on this to take them where they needed to go. And it's wonderful, right? It removed a lot of stress from driving. No more your passenger seat person yelling at you that you missed a turn. And you could go somewhere by yourself without having somebody next to you watching the map. And you could, you know, navigate safely in a foreign city without having to all the time being on the lookout for signs and stuff. It also had some negative impacts, if you want to say negative. For example, people weren't learning the layout of the cities anymore, right? If you started driving and from day one, you've been using a GPS to get from where you need to go. If you went to somewhere with a GPS and next week you had to go there again and the GPS was gone, you couldn't find your place, right? Because you were relying on, you know, the friendly lady or gentleman in the GPS telling you where to go, and you weren't paying attention as much as to where you actually were going. So it changes the fundamental mental model of people that they had about their cities or that they were traveling in. But this was the sweet spot. This was sort of, to my in this model, to my understanding, the moment where this impacted a lot of people in a significant way. It fundamentally changed the way that people drive. And then people were like, crap, TomTom and other companies, of course, that have made these things, what else can we do to this thing that's already so amazing to take people from A to B? Let's add features to it. And I'm not making this up. a later version of the TomTom navigation device actually had a photo viewer with a slideshow feature on it. This is for a device you're supposed to use in your car while you are, driving. Of course, there was probably a safety warning that don't look at the slideshow unless you are like, parked or something. But you can see they were clamoring, they were scrambling to find more things to do with this. And then they realized, hey, it's basically a computer, so we can run all the kinds of things on it that we can do with a computer. So let's do a slideshow. Right? So you could upload photos and look at them. But yeah, so now you have a GPS that you can also look at photos through. But that didn't add anything near the life-changing value to the device that TomTom or your GPS did in the first place when it had reached that sweet spot. I'll show you another example. Cell phones. In the mid-90s, you could go and buy a cell phone, but it was basically, that's why I'm showing a box from DigiKey here, which is an electronics supply store. You would basically get a bunch of electronics, right? And you could somehow cobble together a cellular phone if you had the right circuitry and things like that. And it was definitely just for people who really, really wanted to be on cellular. Then the professional phase came, and these were this is a mobile phone from like, the late 90s that was still carried around in a suitcase, okay? But if you were a traveling salesman, a sales representative who had to go to clients, and you were on the road a lot, this was great, right? This was not like your CB radio or ham radio. This was not a radio kind of thing. This was really, you could call people on the normal landlines from your car, which was unheard of. You had to stop at a phone booth before that. So it really changed people's life, and people who were traveling a lot as part of the job, for them, it was worth it, right? Being reachable on the road. But it was a big chunky thing and expensive, of course, as hell. And then came the consumer phase, of course. And this started with devices like this one here, this the Bone, as they like to call it, the Motorola Bone, that, was clunky and big, but you could actually hold this in one hand, and it ran on a simple battery that was in there. And you could talk to people while you were walking down the street, right? And that, of course, changed fundamentally how people were starting to interact, right? You may not know this, but there was a long time before that where if you agreed to meet somebody somewhere at a certain location, let's meet at 8 p.m. at the Rathaus in Aachen, you actually had to be there at that time. And there was no way to reach that person 2 minutes before and say, oops, sorry, I stopped into that shop and I'm going to be 5 minutes late. You couldn't, right? So people were like, actually had to be in places and times at the right time. They could not change their plans. Now, this has completely changed these days, of course. And that's what I mean by a life-changing device, right? So I would argue that the Nokia 3210, I guess this is one of those early models here. These were the sweet spot of just mobile phones. I'm not talking about smartphones here, right? I'm talking about the mobile phone as a functionality, as a technology. That's when it hit the sweet spot. A thing you could literally put in your pocket, would run on days on a single charge, believe it or not, and that you could use to reach others and be reached. This is life-changing, right? What happened to the mobile phone after that? Well, there was an unhappy time in the mid-2000s where everybody now had one of these Nokia phones, but you had to do more, right? You had to sell more phones, new features. So people started building things like this, a Compaq or HP PDA, or the iPac it was called. This was essentially a mobile phone, but it had a day calendar on it, and it had probably even an email client on it, and all that kind of stuff. And as you can see, this was basically designed like a tiny little Windows machine, right? It even has a little Windows logo and a status bar and a menu bar sort of at the top there, and tiny little icons that you could only hit when you used a little plastic pen. So they were trying to cram more and more things onto the phone because, hey, it's a computer, right? It's universal. You can run code on it. So let's do that. And of course, you add a color screen and you make it a little bigger. And so what we saw for a while there, we ran a study actually for a German magazine that you may know, Connect. It's kind of like a mobile technology magazine, and we ran a study for them in the late, I don't know, 2011 or something, or 2010, and we were trying to compare different phones and how people used them, and it was becoming very clear that if you got one of those iPacs, you had no idea how to call somebody. It was so difficult to actually place a call that people struggled doing that fundamental function that you were supposed to be doing with a phone in the first place, right? It was overloaded with features, clearly very Baroque. Now, there may be a way out of the Baroque phase, but to get out of the Baroque phase, you need another game changer. You need another game-changing invention, a game-changing innovation, a step forward. And this, of course, was in the case of smartphones, the idea of let's get rid of the keyboard. Let's make it a fully touch-based device, which, you know, the iPhone did, which very quickly cleaned out everything that had gone on before it with these so-called smartphones. So that was needed because then you have a blank slate and you can put a UI on there that matches the current task. You had way more space for explaining what to do, bigger tap targets that don't require a pencil to hit them. So then it becomes, you know, a game-changing device again. But that's how you get out of the Baroque phase. You need another, you know, qualitative change, I think. And this is my theory, right? So the Baroque phase is something that I added to this model. There's a paper I published about it years ago. And the idea is really literally that this is how you see technology evolve beyond that original phase. So just to explain, maybe this helps to better understand whether you're looking at a sweet spot device or whether you're looking at, you know, the Baroque phase. A sweet spot device, when you reach that sweet spot, really simplifies your life, right? The TomTom totally simplifies your life. You've never gone from A to B easier than with that, right? The navigation GPS. The TomTom with an additional photo viewer on it and maybe an MP3 player and you know, a slideshow and probably a video player and an address book and whatnot, it actually, compared to the simple TomTom that just takes you from A to B, complicates your life. It becomes more difficult to manage. You need to install more software updates because, you know, software needs to be fixed. You know, to get to the key functions becomes harder because it gets cluttered with more stuff that you don't really need all the time, but it fills up the UI. So the feature creep, and as we call it, like features creeping into the tech, is a clear sign of the Baroque phase. Whereas the sweet spot really has this one rule-changing new functionality that has been, you know, optimized for use, for simplicity. And so that's the difference. I think microwave, right? You know, when the first microwave came out, that actually was a microwave. You know, and by the time it got in a very simple device where you set how long and how hot, that's a game changer, right? You know, you reheat food completely differently, changes everything happening in every kitchen in the world. But the microwave that has, you know, 15 different de-thawing programs and a very complex UI, then becomes, you know, overloaded with features, and it's not the same kind of game changer that the original microwave was. So, and that, you know, to come back to your question about the Apple Watch, or the general, I think you said smartwatches, right? The smartwatch per se. Where are we with that? What do you think? To answer that, you kind of need to think about what is the watch's sort of, what do we define as the functionality that we want to look at, right? What is it supposed to do? For example, with phones, you saw there's a different sweet spot if you talk about a phone that's just supposed to call people and maybe send an SMS, or whether it's a phone that's also supposed to be used for mobile gaming, for example, where, you know, that was a different phase. Marco, go ahead.
Yeah, to me, smartwatch, it feels like it's actually a Baroque phase, simply because, well, watch itself, you could say that the hand watch was, in a way, this like being the sweet spot. So you had, back in the day, you had a watch, which was just like this, you know, this big thing with, you know,
yeah,
with this thing,
a wall clock.
yeah, like those old clocks, right? And then like it got reduced being like, let's say this big, you know, that you would just hang on the wall, and so on to the point of being on your wrist, which was, I can imagine like a big feat. And then I can imagine then, for example, maybe putting an alarm could be, let's say, a sweet spot because it helps you in your life. You know, you put the alarm, you have a clock, and that's it. But then, in my opinion, smartwatch is the Baroque phase because they just put really a ton of stuff. You know, like something like you connect it to your phone, it can read your, I don't know, pulse, it can do this and it can do that. And then, in my opinion, at least maybe because like I never used really smartwatch, I only seen it. So I'm kind of like behaving when it comes to it like some kind of old timer who cannot adapt to technology. But
yeah,
to
get off
me,
my
it feels
lawn,
really like
right?
yeah, it feels like Baroque phase. It's just like they're just like putting a lot of features in it, and it just seems like it's complicating life. But I mean,
So,
it has
yes,
it has its own reasons. But yeah,
when you define the watch's key thing as a timepiece, right? Something that tells you what time it is. I would perfectly agree. I think if you look at a watch just as a device that is supposed to tell you reliably and effortlessly without having to be looked at what time is it, I would probably say this is pretty much this is the sweet spot. This is a what is it? I don't know. I think it's a Casio. It's a watch that has an analog and a digital display to show you the time. But the mechanical watches, you need to wind up every day, right? That's even the watches on your wrist. So that's a hassle, right? That got removed with batteries, but then batteries would run out at the most inopportune moment when you're like in the Gobi Desert and you're supposed to, and suddenly your battery dies. So that sucks. And this one has a solar panel built into the display, and it's just enough to keep charging itself. This has been running for years without me doing anything to it. Second thing is you want your watch to show the right time. Again, mechanical watches were drifting by minutes a day. If you got really good, they maybe got it down to seconds per day, but they were imprecise. It's a mechanical watch, right? Then we had digital watches, and digital watches used to be okay. They would maybe drift by maybe a few seconds per week, right? That was your average cheap digital watch, but they were not perfectly precise because the quartz in there was vibrating at a frequency that would maybe drift off a little. And so what this one does is it has a receiver for the atomic clock signal that comes in via a radio frequency. And so what that means is I also never needed to set this. Right? It would always be correct. And it powered itself through the solar panel, so I never needed to change the battery. This is when you come down to tell me what time it is, and I don't want to mess with anything, right? I don't want any hassle, zero administration. This is kind of where you get to the sweet spot just for the timekeeping. But if we take another look at what a watch is, if we say a watch can also, sense your pulse or show you messages without you having to take your smartphone out, this view may change. But I would agree that as long as you say timekeeping is what you need, this is it. And the watch that has 15 other functions on it, like a calendar and whatnot, but it still has this tiny display and it has a bad UI to maybe even a tiny little keyboard for your calculator on it, right? These calculator watches, that is very Baroque, right? That's overloaded and too crammed in too little space. So for that, it needs a different UI and a different approach. Now we can hear what the other folks have to say. There's quite a few people lined up here. Pascal, go ahead.
I would say that the name smartwatch actually should be a relic of time because it's basically a wrist-mounted computer. And I don't even know why you should even call it a watch anymore. I mean, it basically is a full-on smartphone in a smaller, let's say, form factor. And all the functions you mentioned, it's insane how quickly they developed and how we adapted to it and saw it as the new standard to fulfill for each and every watch we wear on a daily basis. And
right.
I guess that's weird sometimes.
Yeah, I would agree with that. For example, one thing that I never realized, but my wife told me, because she has an Apple Watch too, and she says, what's the greatest thing about this? I don't have to take out my cell phone all the time anymore to see if somebody sent me an SMS, what it says. I'm like, but what's the problem? You just pull it out of your pocket. And she's like, yeah, pocket. I'm a girl, right? So she's not wearing things that have lots of pockets that big chunky, smartphones fit into, or if they do, then it doesn't look good. And so if you always need to pull your smartphone out of a handbag or a backpack or whatever, a satchel, that's a lot of hassle. And for that, for example, the smartwatch is a game changer because it shows you your messages. You can take a quick glance and see what the SMS is about. Someone sent you, then they texted you without having to pull out your phone. So yeah, with all these new functions, then the smartwatch no longer looks like a Baroque thing. It looks like something else. And let's hear the other folks then. There's no right or wrong answer to this, right? It's just trying to reflect on this Baroque phase thing. Janos.
Well, I have a comment on this, but I want to preface it with a question regarding. You mentioned to exit the Baroque phase, you need a qualitative shift in some big way. But is it possible for a device to be in kind of the enthusiast phase because it has a large, like a substantial feature, but it only applies to a very, small subset, but it seems Baroque for everyone else because most people don't need to use this feature? Like,
yeah.
Where it's an important shift, but only for a small use case.
Yeah. So I think you're right, and that's probably a better way to describe it than how I said it before. Because of course, the thing that gets you out of the Baroque phase won't typically lead immediately to another sweet spot device. You will typically enter a new phase of technology, and you will stumble your way through how to do it. And this again takes me back to the fact that things are never invented by one person alone, right? It's not like there were all these bad dumb phones with lots of features on them, right? These feature phones that had lots of extra stuff on it with a bad UI, and then somebody woke up at Apple and Steve Jobs said, oh, here's the iPhone, ta-da. That's not how it happened. The precursors of the iPhone had been out for 30 years and had been technologically worked on, and they were, I would agree, if you bought like an earlier version of that, if there were even for sale, right? The IBM Simon, for example, from the 80s, right? This touch screen phone from the 1980s that had a home screen with icons on them and stuff, like with apps essentially. That was definitely not as user-friendly as the iPhone was, but it was a new approach. It was already showing us the seed of how you could do things beyond that phase. Although that phase with the overloading of the phone hadn't even happened yet, right? That's the interesting thing. So in the research lab, you see aspects and facets developing that are already the kernels of solutions, the seeds of solutions that we will later use to solve problems in the industrial product realm. So that's the tricky thing. We're not telling one single line of history or A and then B and then C and everything built on top of it. It's these at least two, sometimes more different phases that happen or development lines that happen in parallel. But to cut it short, yes, I think a new idea will take people out of a Baroque phase and have the potential to start a new product category, essentially, like moving from normal phones to the touchscreen-based smartphone. But it doesn't necessarily mean that the first product that comes out or the first prototype that ever comes out of this is already the solution. You had a question too.
No, just that's like the question was regarding that shift, but I would argue that the smartwatch kind of resides in that territory because phones do a lot of what the actual functionality that it provides. So like checking your messages, you can take out your phone, check something, whether it be from a purse or you can like receive email throughout your day anyway. But the convenience of doing it hands-free, the convenience of most, or I don't know about most, but a lot of interactions don't even require input really. It's just acknowledgement. It's just receiving information. And having that translated to a form factor where the information is literally just a buzz on your hand compared to having to read something necessarily, or if it is reading something, it's glancing at something while you're walking. Rather than taking out a device from wherever. It can be a radical shift if your lifestyle demands it. But I think that for most people, the features aren't like big enough for it to be like actually perfect. Like I don't think everyone needs one, right?
Yeah, absolutely. So agreed. I think when I got an Apple Watch, it actually took me a while to understand what it would mean. And funnily enough, probably the most, I don't know, maybe one of the most often used features these days is to find my frickin' iPhone, just to hit that little button on my watch and make my iPhone go bing, right? Which is sad because that means it's basically a self-fulfilling service, right? So if I didn't have a smartphone, I wouldn't have to look for it, right? But the smartphone has become so much sort of something that people expect you to carry around, right? talk about COVID passes and all that kind of stuff, that nowadays I need to have it. So it's part of my life. And then that makes things maybe a little more complicated to have to carry a smartphone around, but then the watch makes it easier to actually find it when I'm heading out. So there are interesting things that people then discover with these new devices that they do with them. And oftentimes they are not the ones that were originally intended. As you probably all know, SMS was never meant to be a messaging service between consumers. It was originally designed as a technical way to pass tiny bits of data between devices for maintenance and service purposes. So SMS was a glitch. It was basically in the system, because obviously data is being transmitted over a digital channel ultimately there, and they could send a few bits of text, to send these short messages between devices. It was never intended to be something that everybody would use. And then it totally, spiraled out of control and became this awesome feature that nowadays people prefer texting over, calling somebody. I would love to see the faces of the original designers of the first SMS, system. I'm sure they did not expect this to happen. Just like the designers of smartphones or the cell phone certainly never expected people to call each other from 15 meters apart at a busy party, right? Just because they can't see each other, they're like, "Hey, are you still there? Yeah, I'm over here. I'm waving at you." That is completely, ridiculous for somebody who originally made up a cell phone. They were imagining people on the go out there, right? No phone booth inside, right? These days, we don't even know what a phone booth is anymore. So it's interesting how technology gets adopted. And there's a whole theory that's an HCI theory. It's called appropriation. Appropriation means a user base takes a technology and adopts it and makes it its own, and often does things with it the designers never intended. Now, I hate to do this, but I think we need to cut the discussion a bit short. Otherwise, we're never going to get through anywhere. Like Oliver is already smiling at me. We're never going to get anywhere close through the things we want to still cover. So please hold on to your questions. Maybe Ollie, you can have a discussion in the lab about these things. Make a little note, folks, what you wanted to ask and discuss, because I'm sure there are interesting questions and things to discuss, and we should bring them back. So Ollie will take your questions and discussions in the lab. And if there's something we want to take back into the lecture, we can do that next week. Okay, now I'm gonna
short note. Next week is the midterm exam. So
okay, whenever I say next week, I mean like next time we have a lecture. I'm sorry about that. Yeah, that's a semantic mapping you will all have to do for that. Okay, I think we can go on to the HCI visions now. The HCI visions is a section where we're going to talk about how people in the recent past thought about the future. Right? There's lots of directions we're going to where you could follow. We're just going to present a few selected trends here. This is watching videos. And watching videos, why are we watching them? And how should you be watching this? What should you do with your brain in the next few minutes when we watch these things? We want you to ask yourself a couple questions. You will see visions of how technology could work from the past, right? Ask yourself, which of these things have actually become standard, have become just like they were predicting? And which aspects have not become standard, right? So what's normal today and what totally disappeared, or what was done completely differently from how they were imagining it, because of course these things will be wrong. And sometimes you will see visions where you'd say, actually, even today, we haven't reached that yet. And these visions we're seeing are like 40 years old, right? So, or 30 years at least. So we should expect these things to have happened, but not all of them have. And then if you can try to put yourself into the shoes of the audience back then, which is hard because this was before you were born. But think about, you now know a little bit about the history of HCI, what was out there at the time, right? You know what was out there in the early 80s, for example. From the audience's point of view back then, what do you think the vision was provoking in the audience? Anything positive, negative that they were thinking about? And then finally, there's the author's point of view, where you can ask yourself, so what were the key new ideas that this thing proposed, right? Just like with the historical systems we've looked at, and how was the vision prototyped and communicated to other folks? The first one we're going to see here is called Put That There, and it's an example of multimodal interaction. It's from MIT, and it's from 1980, and that should tell you no IBM PC yet, no Macintosh, no GUI for the masses, right? Not even the Star had been released yet. The Alto was there, but wasn't really being sold. And so in that time, somebody at MIT posted this, put that there video. The key advances you're going to see here is recognizing human gestures, arm, finger, pointing gestures, and combining that with voice. So gesture plus voice. You will also hear some entertaining sort of synthesized speech from a computer, 1980s style. So it sounds very robotic, but that's how it was. And this was actually a working demo. So this was not made up. This was not faked. This technology actually worked. That's also why it's a little clunky, right? It's not perfect. It's not Hollywood style. And I want you to especially pay attention to the voice and gesture combinations we're seeing here. And think in your head, how would I code that? What does that mean for the software to do? Okay. All right. So this was put that there. As you can see in there, there were a couple things going on in the video that are not trivial from a coding point of view, right? For example, if you notice what the computer was listening to, it wasn't just the voice input from people, but it was also recognizing where people were pointing, right? It had a little one picture shows this briefly. If you look at the video again, there's a little tracker mounted to the finger, and then as you move your finger around, it can tell where you're pointing. This is the key thing here is that the software, the AI, because this was sort of in the first wave or second wave of AI, we're currently experiencing, I guess, at least the third one. This was a combination of multiple incoming signals, right? It had to do natural language processing and recognize words and turn these into commands that it understood, but it had to also look at the same time, pointing gestures coming in. So it had to look at, if somebody says, put that, then it needs to figure out around that time, slightly before or after or in the same time, somebody must be pointing at something. So that must be relevant for me. Of course, it must be recognizing that the speaker was where the speaker was pointing, not the other person. So there's a lot of intricacies going on here in that software that's not easy to code. And especially the two people interaction, of course, and adds another level of complexity to this. So for this, we don't need to go into a long discussion here, but it's something I'd like you to reflect on maybe a little. You've seen voice recognition. Okay, we got, Alexa, Siri, and so on. So we have that today, and we have it in a better way than what this is doing, because we can speak more naturally now. But gesture, I would love my HomePod Mini to understand if I say, turn off that light, right? That would be awesome, but it's not there yet, right? We're not in that hasn't really happened in a consumer level, like it hasn't become an everyday technology. We could certainly do it, but it's not readily, it's not in everybody's home yet, unlike, a broadband internet connection. One thing that I think becomes clear from this also is that privacy considerations are not at all, of course, a topic here. But if you imagine this to be in a home today, and now you've had your system not only listening to you all the time, essentially, but also looking at where you're pointing all the time. So that's a lot of observation happening in a home. So maybe more workplace, less home. Who knows? Right? Okay, I'll take one comment. Henrik, go ahead.
Regarding the gesture control not being there yet, actually I disagree with that, because the Xbox Kinect, the first one, is almost 10 years old at this point, maybe even a little bit more, and that was perfect for roughly recognizing where you were pointing at the screen. What you were saying about turn off that light, I think that's definitely possible, but the devices don't have a use case for that right now, just because of the privacy concerns that you talked about, because you would have
have to film yourself in your home the entire time, and I think that's nothing that's able to be done today anymore.
Yeah, it makes people a little uncomfortable. So very interesting, right? If you think about this, you're right. And don't get me wrong. I think the technology is there, no question, right? And even the consumer devices are there that could do this, but the use case isn't something everybody is doing. Like everybody is online with their smartphone these days, right? That's not a question, right? That has fully arrived. But being able to, or pointing at your light and turning it off with a voice, that's not something everybody does. This is what I mean by has fully arrived in society, right? And yes, there are sometimes things where just our priorities as societies shift, and we focus on doing things in different ways, right? So nowadays, privacy concerns are much bigger, and these solutions, if they were ever to be released in a home, would probably likely have to be some kind of local edge computing kind of thing that had a secure way of knowing that Big Brother is not listening in when you're at home. All right, next up, multimodal interfaces part 2. Apple Knowledge Navigator. This is a video from 1988, and it's a mock-up. So this was not implemented. This is a vision video mock-up. And the key thing you will see here is that it gets people excited and enticed about the idea of two things. First of all, an intelligent agent that is working with you, that is your personal assistant, basically. And that's the guy with the little black tie there that you see in the left in the image. And secondly, it got people excited about the use of multimedia, and not just multimedia locally, but also sharing multimedia with people across a network. The Apple Knowledge Navigator itself is essentially a device. It's kind of like a flip open, you could say, iPad, and the story you will see, I need to explain this because otherwise you might get lost, is a university professor who's a geology professor or geography professor, and he's in his office and he's trying to prep for a lecture, and he needs some kind of help from a colleague that he sort of recruits to be part of his lecture in a video call to answer some questions. And then there's also a little family drama going on in the back because this is his mom is calling all the time and reminding him to do certain things. So that's what we're going to see here. And this is much more professionally made because this was created as a vision video by Apple, by a company, as opposed to a research institute like MIT. All right. Okay. So this was basically, I'm going to try maybe switching the share over again so I can see you guys. Okay. Now the participant list is back. Good. So a couple things you may have noticed here. First of all, I don't know about you. I haven't seen a MacBook yet that I can unfold like that, and the screen is just perfect in one piece. Doesn't seem, although foldable, rollable, flexible LCDs are, we keep seeing them at trade shows and CES and so on, but not quite something everybody has in their home yet. And then, of course, there were things, if you think about what the AI was doing here, that were quite outlandish, right? It was completing sentences for that person. It was able to answer highly fuzzy requests with a lot of semantic background, right? You say things like, there was an article from a guy called, he really disagreed with the research, Jill's research directions. Wow. That means that thing not only needs to have access to, basically the digital library, ACM digital library, that's easy, but it also needs to understand what these papers are saying, and then need to understand whether one is disagreeing with another one. Welcome AI, right? That certainly didn't happen in the last wave of AI that they were imagining, and it hasn't happened in this wave of the AI yet. But we are inching toward that, right? To text understanding, of course, has made giant developments, and especially in the last years with deep learning networks and bottom-up AI systems and black box AI approaches. So we're getting there, but nowhere near the sort of everyday casual usability that this was proposing. Some other things, like the network, the video conferencing. Jesus, I mean, we're talking via Zoom right now, right? So that totally has arrived, and has arrived for a while now, and is there, of course, as an interaction, and is sharing desktops. I mean, that's literally what we're doing here in class. So these things are, you know, they were spot on. They did happen. You may have noticed there was a year mentioned, right? So this was supposed to be happening somewhere around the time 2007, 2008 or something. Like there's an article a few years back, and this was an article from, I think, 2006 or so. So this is sort of placed around that time, and the video was from '88, and they probably wanted it to be taking place like some 20, 25 years in the future. So it's somewhere around the sort of 2007, 2010 timeframe, roughly. So that tells you what they were thinking would be there by that time, and you kind of know what was there by that time. Okay, so that's Knowledge Navigator. I'm going to show you, oops, no, not again. I'm going to show you one more, Sun Starfire. This was done in the early 90s, so a little after Knowledge Navigator, but with a very different premise. It's also a video prototype of a future communications and computation system, sort of the workspace of the future for the office worker. It was done by Bruce Tognazzini, or his short name is Tog, who was in the human factors engineering group at Sunsoft, at Sun Microsystems at the time. Tognazzini also happens to be one of the key designers of the Macintosh user interface before at Apple. So by '92, he had moved on to Sun, but he's written a couple of books on the topic, Talk on Interface and Talk on Software Design, that talk about his work. Very, very interesting reading. The goal of this video that Tog made there at Sun was to show a system that would actually be realistic in 10 years. So they were only giving themselves a 10-year time frame. The Knowledge Navigator was sort of assuming roughly 20, 25 years, which is way out there, right? And so 10 years is actually much closer, right? So from '94, the story actually takes place on November 16th, 2004. So that's a long time ago by today's standards, but back then this was 10 years in the future. And so you can take a look at what these people were expecting to be there 10 years from, you know, their recording date on. Again, make a little list of things that are totally realistic now, and a few things that are not, right? So again, to give you the story here, you're going to see an office worker who's a car designer, and she's working at a graphical workstation, designing a car and bringing, you know, parts together from different colleagues across the world. She will be interacting with via video conferencing, and she'll be driving remote cameras to make shots for the presentation that she needs to give in front of the whole board. She will be working with a big desk that has a continuous curved surface from the vertical to the horizontal, and that's a giant touch screen that she's interacting with. And the system, of course, also has voice input, but she does a lot of interaction by touching and moving things around on that desk. She'll be using some Office apps, like, you know, an advanced version of Photoshop, you could say. She'll be talking to her family at some point, or who are having lunch, and she needs to sign some papers, and they somehow do that via video conferencing. And then we'll see a cut over to the boardroom scene where she presents and has some interesting help from her colleague live in her presentation, bringing up some data that she can use in her presentation. And this, of course, there's the nemesis, you know, the other guy who wants his car to be built for us, and we'll see how that goes. Okay, all right. So that was the next video, and as you can see, this is taking a very different approach to what Apple had been doing, right? Here we are really looking at, if you want, a vision that was, as Bruce Tognazzini put it, this was something that everything you saw there was actually around in research labs already, and looked like it could be released to the general public as a production system, you know, at least in a work context, within 10 years. And that's why some of the things were a little more conservative in terms of their, you know, vision of the future than what we saw in, for example, the Knowledge Navigator, or the example I've put that there. One of the things that came out of this too is video prototyping guidelines. This was a very involved process to create this video. I mean, you see, this was like a 15-minute feature that was, you know, professionally made with lots of obviously fake interactions going on, lots of video editing to make this look as if it was working. You know, Bruce Tognazini, being who he was always interested in analyzing the process that he was going through, not just building stuff, but actually understanding what was going on. Pulled out of this process of making this Starfire video a few guidelines, because video prototypes are surprisingly tricky. First of all, for this one, they said, okay, 10 years. So they continuously ask themselves, are we still in a, you know, realistic assumption here within the 10 years? Because it's so tempting to just make up stuff as you go when you are in a video prototype, because it doesn't have to work, right? You can just show something magic, right? You know, in the knowledge navigator, the guy says, you know, find the paper that disagrees with Jill's research, and boom, it's there. You can say that's, you know, that's what's happening. You're making an assumption, but it's easy to make that assumption because you don't need to actually, you know, build a working prototype. You're just showing an idea, like in a sci-fi video. So continuously asking yourself, are we still realistic within the time frame that we ourselves set us with this was an important part. And then they iterated this video just like any other prototype. Now, the class you're taking, DIS1, consists of 3 parts, right? We've talked about human. We are now talking about, you know, HCI as a field, and then we will be giving you in the 3rd part, arguably the most important one, we'll give you the tools to do iterative prototyping yourself, to actually build great user interfaces in an iterative process. And that's what he's saying in this comment that he wrote on this video, that you need to do that same thing with your video prototype. You need to iterate. You can't just make one script and roll. Another thing that you may have noticed, did you notice that, you know, first she scanned this piece of newspaper, right, by swiping over it with her hand, which is kind of cool. And it was like, huh, nice idea. And then a couple of minutes later, she accidentally scanned her sandwich, right? It was actually, you know, digitized, and she removed it by like wiping it off. That's a bug, right? That's a bug that of course wasn't there to begin with, because we're talking about a video prototype. A video prototype doesn't make mistakes unless you write and film the video to show a mistake. You need to actually, you know, craft that mistake yourself. So Bruce Tognazini and his team went in and actually made up things that would go wrong in the story. You saw another example where it said vocal command not recognized as she was practicing her speech that she would give in front of the boardroom. There are a couple things in there where tiny things go wrong, and that's intentional, right? It's showing that the team, again, thought about the realism of their system and what would happen if somebody made a small mistake. Because as we know from Norman's book and what we talked about in class, mistakes happen. People make these tiny mistakes, these slips all the time. How does the system recover? So by actually adding things that go wrong in their video, they also were able to show how the system would respond and how it would fail gracefully. Well, then avoiding impossible hardware designs was a goal for his group, and making sure that they're not just making stuff up that is completely out of the question, and designing the interface first and kind of committing to a particular design of the UI and then filming the scenes using that interface design. Because it's so tempting to just basically tweak your vision of the UI as you go. You say, oh, it would be nice if now it would recognize speech, and now it would recognize this gesture, and now it would not recognize this gesture. And so that you don't contradict yourself and make something that couldn't possibly work in real life, you have to kind of like commit the interface design at some point, and then, you know, create the story around that. And if you need to change it, you iterate over both of these as you go. We saw some examples here, like for example, there was a lot of reverse angle shots where you look at her face looking at the screen. You don't see the screen. Why? Because it's much easier to show her face than showing a screen that actually works, right? Because there was no screen that was working. This was all video edited for the video prototype in post-processing. That's why we have the article that I just talked about. It's a very short one, an easy read, that talks about the video prototype and talks about the case study of what was going on in that video prototype. We'd like you to read that article. It talks about the video prototyping guidelines that evolved out of this project. It's online in the digital library, but you can also find it here at Bruce Tognazini's personal page. If you want to learn more, this is not a required reading, but a recommended one. You can take a look at Bruce Tognazini's book, Tog on Software Design, which was actually supposed to be called Starfire in the first iteration. And then finally, I have an interesting twist for you guys. This is the original Starfire desk that you see here. And a couple of years back, we actually went back to this idea that Tognazini had created there, because nobody had ever built this system, right? It never existed. It was just a fake. And we built one. So we were able to create a curved screen display that was a continuous display from vertical to horizontal. You can see it here in use. This is one of my former PhD students, Christian Korsten, using it. And you could interact with stuff. You could move them around. You could move things through the curve from the vertical to the horizontal. So this was a wonderful thing to build. And actually, we had Bruce Tognazini visit at one point. He gave a talk here. I invited him over to the university, and he gave a presentation. And when he saw this thing, he was all over it, right? He crawled through our construction and checked out how we did it with the projectors and stuff. He was very excited about this. Okay, so that's Starfire and its vision. When we go and look at what other visions are out there, there are a few more things I want to briefly touch on before we wrap up for today. And the first one is virtual reality. I'm not going to go into detail on this because it's a whole story. It's a whole sequence of lectures by itself, right? You can have a whole semester class on virtual reality by Professor Thorsten Kuhlen. I highly recommend that. It's an exciting field. But again, I want to show you when that first blip of virtual reality hit, the radar of the research community, and that was in 1967. You can see here Ivan Sutherland. This is the same Ivan Sutherland that just a few years before had built his NLS prototype, who had then gone on and built a head-mounted display, which I do agree looks a little bit like a scene out of Brazil, the movie. It's like it looks like a torture device more than a display, but it is actually a VR display. And of course, the idea of virtuality, the key advance that it brought to HCI, was producing an illusion of being in a completely three-dimensional world of computer-generated objects. So mostly visual, but also sometimes auditory, right? A simulation. And what I think is interesting about VR as an interaction methodology is that we can now basically tweak and twist all the interactions you do with your real life. So there's interesting work in HCI, for example, that says if I'm pointing at something in VR, I can actually, and you're moving your actual finger and you're not seeing it because you're wearing VR goggles, we can actually make it so that you point something slightly elsewhere in VR, and you're not going to notice the difference because your muscle memory isn't that precise. So you can fake sort of the input that the user creates to the VR environment, and you can map it to what makes more sense. VR is a super exciting world to explore. Personally, we have not done as much work in VR. We've done a little bit, but we've done more work in augmented reality. And that's something you can hear a lot about if you attend the current topics in HCI lecture next semester. I don't want to get into VR more here. What I want to get more into, because it's, I think, even more relevant to HCI as a discipline, is the field of ubiquitous computing. This was a field that was actually, coined by Mark Weiser, who also worked at Xerox PARC, that same place that created, the Alto, created the Star, created Ethernet, created the laser printer. And he coined this term in 1988. So we're talking early here, right? We're talking, the Mac had been just out for a few years. And, everybody was getting used to graphical user interfaces, and the multimedia revolution, as they called it, with CD-ROMs and stuff, wasn't even there yet. But the interesting thing that Mark Weiser came up with is that he wrote an article in 1991 that sort of nicely summarized his earlier ideas, called The Computer for the 21st Century. And I want to briefly go over some major points that he's making in this article. He's proposing and suggesting that the most profound technologies that we work with actually become invisible. Not in the sense that they are invisible a la, Guardians of the Galaxy kind of way, but they are becoming invisible in that we don't notice them anymore. Here's the first example. Writing, I think we all agree, is a very fundamental technology. And it used to be really complex. You had to kind of like, know how to make ink and bake clay and whatnot. And today, writing is everywhere, right? You got writing on candy wrappers. You cannot imagine a modern world without any writing in it. It's impossible, right? So it has become ubiquitous, which just means it's a fancy word for saying it's everywhere. It's permeating reality in all directions and all levels. If you compare writing to the example of IT, computers, they are still at kind of the scribe stage, right? I think when you look at computers, desktop computers and laptops and so on, you still need to know a lot of the maintenance of these things. You need to know how to update your Windows, and you need to know how to charge your battery and all these kinds of things. It's not quite as bad as having to know how to bake clay, but we are dealing a lot with the administrative gunk, around IT that our normal users shouldn't have to bother with. It's gotten maybe a little better with things like, our smartphones, where you can download apps. You don't need to worry about where to install them and what folder and what rights they get and how they update and how you find the updates. It's gotten much more streamlined. But much of IT is still at that early stage. It hasn't disappeared in our cognition yet. It is on the way there, but it hasn't disappeared yet. Here's another example that I like a lot. Motors. In 1900s, when the engine, the motor engine, was introduced into the industrial production and sort of, within the Industrial Revolution, it basically meant that you had one steam engine per factory, or maybe later on an electric engine, right? It was a motor, and that engine was super complex and costly, and the entire factory worked with belts that were bringing that motor energy to the workstation that needed it, right? So there were 15 workstations doing things, and one motor was supplying them all. It was, via belts that power got delivered everywhere, because it was super complex. So the motor was very much on everybody's mind. Let's hope that one motor doesn't break because our factory stops working. And nowadays, you've got tons of motors in your car, right? You got motors to lift your windshield, your windscreens and the door. You got a motor to move your wiper around. I mean, you even have motors to flip your mirrors in and out, right? There's lots of motors. They're actually almost unnecessary, hard to notice. They're almost invisible because we don't pay attention to them. So cognitively, they have faded from our consciousness because they work so reliably. They're so small. They're so cheap to can put lots of them inside in a car, for example. So that's how technology sort of permeates reality and becomes ubiquitous. Today, the motor has become a ubiquitous technology in our devices. It didn't used to be 100 years ago. The article from Mark Weiser describes a couple scenarios how he envisions computers to work in the 21st century if they are really supposed to become ubiquitous. And the first scenario that he describes is one where somebody's making themselves some breakfast and then looks out of the window, and the window shows in an AR display, shows the tracks of the neighbors. Oh, look, we don't really have snow outside, so there are no real tracks of the neighbor leaving their home, but the AR system shows some virtual tracks overlaid on the green lawn of the neighbor's house. And that's comforting to know. Oh, our neighbor has gone to work like every day they do. Normally I see them walk out of the window, but I can see they've already left, even though it's not winter and I don't have real foot steps that I can see them virtually. And of course, immediately we see this is cozy and nice and helps, be aware of what our neighbors are doing, which makes a good neighborhood, but also it has issues of privacy, right? Obviously. Another example in there talks about, the person still reading a paper newspaper and looking at it. But when she reads something interesting, she marks it up with an electronic pen, and that digitizes what's in there and automatically puts it into her personal database of citations and quotes and information that she wants to collect. Another example is, she's lost her the manual to her garage door opener because it needs resetting, and the menu, these manuals for little gadgets always disappear, right? They always somewhere. And what this Ubicomp scenario imagines is that the manual in its written form, just has a little tag attached to it, a little blip that is trackable, right? And that will tell her where she left the manual. What we're talking about here is like tiles, right? Or air tags, right? Apple's air tags. This is, something that actually in some way has become almost, something that everybody can use and is being used a lot. Another example, then she drives to work and then finds herself looking in her rear mirror. She's not just seeing the cars behind her, but she can also switch her rear mirror into a 4-view mirror that will show her empty parking spots that she can go to or traffic jams. And that is something, that was, again, a vision in '88. And nowadays we have AR overhead displays in our cars that show us our traffic situation. And that is very much becoming a reality. Although the thing with parking spots, still not always, just in very special places. Another example from the scenario is the fresh coffee indicator. What that means is, when you got a group of people working in a lab, they will always congregate around the coffee machine, right? They'll always hang out around the coffee machine, and that's where discussions start and informal interactions start and ideas are being born. How do you do that? How can you build on that to make it work even better? Well, the fresh coffee indicator was simply a little display that she had at her workplace computer that would indicate when fresh coffee was ready, right? It would pop up, kind of like smelling the coffee down the hallway, helping her to detect that, and then she would make her way over to the coffee machine and have a real interaction with her work buddies. So as you can see in all of these, there is a lot of very careful, very subtle interactions that don't mess with your reality or your perception a lot. They are just subtle cues embedded in the environment that we can immediately intuitively understand, hopefully, and that help us navigate the real world just a little better without having to pay a lot of attention to technology. So it's not get out your smartphone and check if somebody has already gotten to the coffee machine, right? It's supposed to be there in maybe on your computer screen on your workstation, or maybe even an ambient light that turns on when that fresh coffee is there. The final thing that the Ubicomp scenario talks a lot about, and that's very heavy in their demo, is a collaboration via devices. And they have different kind of devices. They have very small devices that you would say today are in between an AirTag and a smartphone, kind of stuff, like inch-sized devices that are cheap, that you can attach to stuff like a book, not to lose it, or that you can carry around with you all the time. And then there are pads, which are basically like today's tablets, that you can scribble on and exchange notes on. And these devices are aware of the environment. That's the key difference to what was out there in 1988. All these devices knew in which room they were, in which position they were held, who else was nearby, whether there was a large display, for example, nearby that they could move their content onto to work on it collaboratively. These things were all imagined. And switching effortlessly between these different machines, between different displays, and between these devices is something that was held very dearly by the Ubicomp design team. We'll see a short video that was done about ubiquitous computing by Park that explains these scenarios. And I'm sorry, you'll see a bunch of engineers trying to be actors, and that's always slightly cringe-worthy, but also pretty entertaining. So bear with them. They're not professional actors, right? Imagine yourself having to do this. But you'll see an interesting story, of the devices first, and then of a usage scenario of this thing. And they make the mistake number one that all engineers make, which is the sample discussion they have to illustrate their use of all these devices is about designing these devices itself. So that can be a little confusing. They don't discuss designing a car like the Sun Starfire did, which was a great choice for a sample topic. They actually talk about their own work in the video that is showing their own work, which is kind of confusing. But here you go. Anyway, I'm going to again switch to the audio video share here. Okay. So that was the Ubicomp vision that sort of I find quite relevant for what we're doing in HCI even today. And just one question here to see whether you guys latched onto this. Was there anything in there where you'd say we totally have not reached that yet? Especially when you think about those devices. I mean, it's easy to say, you know, the pad looks like a tablet, and these small things they look like maybe a smartphone or something like this. But what's fundamentally different? I think Frederick, you were first up there.
Yeah, I think the most crucial part that we have not reached is the seamless collaboration across devices. And I mean, across different devices. You can, for example, easily collaborate among MacBooks and iPads. I think I've heard about that. But when someone comes around with an Android phone or Windows laptop or something, this doesn't work. They would need, well, shared software or something, anything. And this normally doesn't work as well.
Right, exactly. So, and I think this is, I mean, of course you could have it. I'm sure you can run, you know, an application specifically that then lets you do that, but it's not built into the very fabric, into the very system that we're using. That's one big difference. The collaboration aspects are ingrained in this notion here that we're seeing in Ubicomp. The other thing that I find highly noticeable is these guys are talking about essentially disposable pads, right? They're so cheap. These little, these tabs, they're so cheap and ubiquitous that you don't even consider them your own anymore, right? They just, you pick one up, like for example, one of those tablets that they've got lying around, you pick one up when you enter a room, and you know, you make sure that it's got, you log on to it or something, identify, and then it's yours for the session, and all your data then gets, you know, out back in the cloud or whatever, and you just put it back on the table because it's so cheap. You can afford not to have to take it with you. And that's something we don't quite see, right? We consider our smartphones, our tablets, very much sort of, you know, personal devices. And if anything, they are designed less for sharing than the old, you know, Unix workstations were, where you just logged on and used it while you were sitting in front of it. So there's still something there in the Ubicomp vision that we haven't gotten to yet, but that to me makes a lot of sense when we assume hardware to become cheaper and cheaper, and that's been true for the last couple of decades. You know, is there a way in which it can become as self, you know, evident and as natural as a stack of paper? I mean, you don't go into a meeting room and grab up all the notepads, the paper notepads, because like, oh my God, somebody left a notepad lying around. That's so valuable. I'm going to take that with me, right? No, it's so cheap that we don't care. But that's not the case if somebody leaves an iPad in a meeting room and you think like nobody wants it, and you probably say, okay, that's mine now, right? So there's your difference in how I think we're perceiving this. So just briefly, the park devices have to know where they are. This was crucial for them to human perception. And even just knowing the room a device is in can make computers adapt a lot, right? Without any AI. If you enter a meeting room, like, you know, your alarms should turn off, right? You don't want alarms to go off while you're in a meeting. That's not artificial intelligence. That's just, you know, basic functionality. So this sensor equipment, that was something I'm sure I definitely would say our today's small phones from a sensor point of view have definitely achieved what Park was envisioning, right? Also connectivity is essentially, you know, pretty much always there, not quite, but almost always there. And those were all visions they had that have become true. The different sizes of devices and tabs on an inch size, you know, pads on a foot size, and boards on a yard size, as wall displays, have also become you know, realistic. With hundreds of tabs, I'm not so sure. We don't have that many lying around, although I've accumulated an embarrassing number of AirTags in my life to mark stuff that I constantly lose. But, you know, dozens of foot-sized devices, not really, right? You may have a laptop and a tablet, like an iPad or something like that, and that's pretty much it, right? It's not like every room has dozens of these. And then, one or two smart interactive whiteboards that you can write on per room is also, you can do it. You can outfit your rooms with that, your offices with that, but it's not common sense. I mean, the projectors are there these days, so that's kind of part of that, but not quite as interactive as a writing screen, as a touchscreen is. The tab was basically designed in '93. They deployed about 50 of these, and they had this idea. They are so cheap and so ubiquitous, you can attach one to each book, right? So that your book becomes findable. And that, if anything, is only possible today with Bluetooth BLE tags. It was sort of thought of as like the electronic equivalent of a Post-it note that can make objects smart, right, by attaching it to them. But it could also be a personal tool that you use for voting or consensus finding in a meeting. You could wear it as an active badge that would let you into rooms because it would let you identify yourself as the wearer or identify the object that it's attached to. And you could take a window from a large whiteboard and just basically zoom it down and put it on your tab to take it with you into your office to continue working on something. And I want to point out something interesting here that can be useful for your own prototyping. This was a design that assumed that basically there was constant connectivity, because of course that wasn't really the case back in '88 or in the early '90s, but they basically just said, let's assume we always have wireless. And so we'd already talked about the question what today's tab would be and what is still missing in the sense of especially being a personal device and not a general device that you just take with you. The pad was basically like a tablet, a crossover between a piece of paper and a laptop. It's a so-called scrap computer, right? It's not a personal one that you take with you, but it's just one that you pick up like a notepad in a meeting room. And it's very different from lots of virtual windows on a screen, right? Because your actual physical desk, the desk I have in front of me, has lots of papers lying next to each other. And so the idea was I got lots of electronic papers in this big physical space rather than trying to cram everything onto my comparably small monitor. So we're still missing things, as we just discussed, especially the non-personal nature of these devices. And then the board finally was basically like a video screen, but also a bulletin board that would actually adjust itself to whether you walked by, then it would show information that was relevant to you. Scary from a privacy point of view. It was also served as a whiteboard that helped people to draw together. We saw that in the video actually as an example. But what they found in this research was that a whiteboard, because you're moving with your arm and you need to do things like this, needs a different user interface from the desktop. That's something people continue to overlook. For example, input with a keyboard is a little bit awkward when you're at this big board. And you don't want a close button for a window that's way up at the top. In fact, at Stanford, there was a short student, and she couldn't actually physically reach the close buttons of windows when they were big up on that big screen, right? That's terrible design. That shouldn't be necessary to having to jump to close a window. And also the sharing across, the Atlantic or something is something we haven't really. Well, we're getting there with whiteboards via Zoom and stuff like this. So that's something that they also clearly envisioned. So Ubicomp is different from personal computing, right? Ubicomp means the computer disappears. It's like augmented reality, or calm computing is a word that we sometimes hear. And the goal is really activating the world. The real world becomes smarter by adding these things here and there, putting computers into everything around us. The PC, the personal computer, and even laptops and stuff, like even smartphones, are really just a transition to the real potential of computing, which will then focus on humans interacting with each other and no longer be technology centric. So carrying one super laptop is like owning one book, but it's a very important book. It's just one, right? That's not really unleashing literacy. So we are on the way towards Ubicomp, and in a way we still are today. One thing that we notice is multimedia, and that's what a case that the paper made in the 90s, but it's still to a certain degree true today. If you add more media and more engaging graphics and stuff to the computer, it makes it more attention grabbing, not disappear into the environment. I think AR has the potential of addressing some of these things. There are some psychological reasons for technology that is successful disappearing in your conscience. Heidegger's hammer is a bit of a misnomer maybe, but there is a psychological, a philosophical theory behind this that is based on some of Heidegger's work. And the idea is if you have a hammer and you're hammering a nail into the wall to put up a picture, you are not thinking about the hammer you're using. You're thinking about the picture and where it will hang and where the nail is going to go. The hammer is a tool that you don't think about consciously. That's called compiling in psychology. The device disappears because it just works. You don't need to think about it. And that's good, right? That's how it should be. But if the hammer is loose, the head is a little loose and it wobbles just a little, you suddenly, your conscious thought starts latching onto that hammer and thinking, uh-oh, maybe that hammer head is going to fly off, so I need to be careful when I hammer. And you are pulled out of this nice flow state of using a tool without thinking about it. So good technology disappears because it doesn't require your attention on the technology to be used. And this is also, Ubicomp is also different from virtual reality, right? VR lets you explore a world that's unreachable, the inside of an atom or Mars, or a fantasy world with monsters in it. But whenever VR is used without engaging the real reality around you, you have to basically try to simulate as many aspects of the virtual of the reality as possible. That's not just vision and high resolution graphics, but it includes sound. It includes the touch of your feet and your hands as you run around a cave. It includes the smell of that cave. So all of our senses are engaged when we interact with reality, and you would have to simulate all of that in virtual reality to really create a high definition version of it and really make use of the human senses, which are pretty amazing. And we're not there yet, right? That's why VR has some limitations that are really, really hard to overcome. And sometimes the question is, why should I overcome them if I can just use the real world and add smarts to it? That's the idea of augmented reality rather than virtual reality. Mixed reality is a modern alternative way of thinking about AR. But from our point of view, mixed reality is really a continuum. On the one hand, you've got VR with no reality at all, no physical reality used, and on the other hand, you have AR that augments the environment with electronics displays and stuff like this. Okay, so we can wrap up, I think, now, since we're already a little over time. Just very quickly here, you'll find some predictions in the Ubicomp paper predicting smaller displays, faster CPUs. They were right on there. They predicted days of use for the devices with a battery. That's actually a little bit optimistic, maybe. The memory that they were expecting these devices to have in a few years down the line was actually underestimated. That developed much better. The large walls that were interactive and that were high resolution, so you could step up to them and read stuff at an arm's length, but you could also look at it from the back of the room, so they were big and high resolution. That is something we only recently achieved with 8K screens. Actually, Ollie and I went over the numbers again, and tens of megapixels is what you need for this at 80 plus DPI for a wall to be serving both the arm's length and the across the room use cases. And our operating systems today are very different from what Ubicomp was imagining. As I think it was Frederick who said this, like, they assume a fixed hardware configuration, and it's hard to exchange things across borders, like from your iPhone to your Android phone, for example. And they were imagining devices just coming and going and connecting and disconnecting all the time, and things would just continue to work. Windows assumes a fixed base computer, and then other things sort of connect to that, but it's really a very sort of island sort of solution in terms of how it thinks about the information. This is getting a little better with cloud computing and edge computing these days, but we're again only on our way to what Ubicomp was envisioning in the 80s, 90s. And the diversity of input devices is also not dealt with very well these days, right? So these little tablets with their touch buttons and the pen input and the input on the whiteboard screen and the microphone and all that playing seamlessly together. With networks, of course, we're much better than what they were proposing, because we have Bluetooth LE. Although there are still problems with multiple connections, I think the technology side of this has gotten pretty much where we are. Ubicomp today has turned to a conference series. There's a Ubicomp conference that takes place every year. There are commercial devices out there that still cling often to the desktop metaphor, and even if they don't cling to the desktop metaphor, they are not plentiful. They're not there to be picked up and used and be thrown away again when you back into the room when you are done with them. I think it's a very intriguing vision. So have a look at that paper where I think he wraps this up, Weiser, with saying like computing should be as calm as a walk in the woods. It's not, we're not seeing anything when we go into the woods. There's lots of input into our senses there, but as we do that, we actually are not disturbed by what's around us, right? Whereas when we enter a room full of technology, it's often quite disturbing. This is a picture of our interactive room at Stanford that we were using around the 2000s, and where we had put up like interactive whiteboards and an interactive table and laptops and stuff, and we were trying to live the Ubicomp life there to see how that works for interaction. All right, last slide for today. Next up, reading a couple things. So we've got a couple required readings, a couple recommended one. I also recommend taking a look at the book Designing Interactions by Bill Mogridge. Bill Mogridge wrote a wonderful coffee table book that has interviews with some of the key people from HCI history in there, and it's wonderfully illustrated, really well done. And every week, I think they put one chapter of it online for free for you to download. So if you want to be a cheapskate, you can do it that way, or put it on your Christmas list. Your parents should get you this book. It's really nice. Take a look at the Buxton collection that features some input devices in there, and is a fantastic, fascinating online collection to browse, to discover input devices you've never heard about. And so we've seen the technology lifecycle today. We've seen some visions, the Knowledge Navigator, Starfire, VR, and Ubicomp. And that sort of concludes our discussion of this sort of historical review of HCI. And we're going to enter a new phase of topics, as I said, about prototyping, designing iteratively, designing in a user-centered fashion. You'll be learning lots of really valuable prototyping and evaluation skills in the next couple of weeks after the midterm. With that, thank you very much for sticking with me, and I hope you enjoyed this little trip down memory lane, and good luck with the midterm. I will stay logged on for a few minutes in case there's any questions, as will Ollie, but otherwise have a great rest of your day. Bye. Henrik, you got a question?
Yeah, perfect. I was wondering, are you aware of the You Will campaign by AT&T that they ran in the early 90s?
You Will?
Yeah, it's a set of advertisements that AT&T started around 1993 regarding their vision of the future. So in 25 years. I thought it was it's a few short advertisements of like 30 seconds in length or even shorter. I think they might fit very well into this part of the lecture. I'll shoot you an email.
Lovely. Yeah. Thank you. Thank you for the pointer, Ollie. That's maybe something we should take a look at. Maybe we can integrate something for next year. That's a great recommendation. Of course, you can also watch Black Mirror, and then you can see all the most dystopian versions of visions of the future that we can have with technology. There's a few out of those out there. Thanks. Marco.
Yeah, I want just to refer to the question that was given here in the chat, the last one. So, which actually I want to ask myself as well. The required readings that you gave us now in this lecture, are they actually important for next week, like the midterm exam?
Those are still part of this history section, and we will be asking about the history section. In the past, this has been part of the midterm. Yeah, so I'd expect those to be in there because we want to make a clean cut. Midterm goes all the way up to the end of this history section, and then we start with a completely different topic in HCI, the whole design process after the midterm. And I mean, in the final, of course, we will be asking things about all parts, but the final will be a little more emphasis on the second part of the class, of course, and not completely evenly distributed. So you got to read them anyway for the final. So, but they will also be part of the midterm. Yeah.
Okay, gotcha. Thank you. Bye.
Sure. Srijit,
Hello, sir. So I had a little question about the technology life cycle. So you mentioned Baroque phase. So I was wondering if one could argue that when a piece of technology is entering that Baroque phase, one could argue that they are exploiting the affordances, the other affordances that the device is providing. For example, flip phones, one can say that a tablet, it does not afford being in our pocket, but a smartphone does. So if we if we increase the form factor of a smartphone and make it foldable, or if we keep the form factor of a tablet and make it foldable, it affords portability. So can we
So
argue?
I'm trying to think here. So I think there's something in there. If we take the GPS, for example, like the TomTom, right? The navigation device. That is a device that is mounted on your windscreen. It has a touch screen. So it has the affordance of being a display and touch input device already. And I would go with what you're saying, that as you can add now additional signifiers, like you can add more buttons to that touchscreen to add more functionality, to add more options of things to do, like a photo slideshow, for example. And the display lends itself to showing pictures. So yes, the assumption that the device supports this is not completely far-fetched. It does support that, and in a way you could say it affords it. The challenge then is, of course, that a touch screen that can display information and that can take touch input affords all kinds of things. Anything running on this old iPhone is basically then fair game to put on a GPS, right? The problem then comes from the fact that the device is no longer a dedicated single task device that I know exactly does this and nothing else, and I can always use it for it, but it becomes this jack of all trades. And there's an interesting, I didn't talk about this in the lecture, but it's an interesting side effect that I've noticed will happen when you do this. For example, people have often said, well, why have a GPS? I can use my smartphone for navigation, right? And GPSs are dying a slow death, right? They're going away, being replaced by either in-car navsats or just your phone stuck to your windscreen, right? Problem is, we're using our phones for other things, right? I've often had the case where my wife says, let me quickly, look something up on the web, and she wants to use my phone for this. And I'm like, no, wait, this is currently my navigation. So you want, in a certain way, you want a dedicated piece of hardware that is just doing navigation. So it's always there, always works the same way. It goes with the car, even if you give it to your best friend, right? And it's part of the infrastructure that you can use your smartphone then for all the million other things. So there are certain things, subtle usability prices that you pay when you start, making things into multi-purpose devices. You don't have two devices anymore, right? So you have to decide to use the one for A or B, and if you do both, then it gets wacky. So I don't even want to get started on all the problems I'm having to get my smartphone to connect to my car these days. It's supposed to be really easy, and it works about 80% of the time, and then it messes up, right? And that you don't have that if you have a dedicated device that is just a simpler, more straightforward setup. That's a good point, though. I think yes, the Baroque phase uses the existing affordances and signifiers and extends maybe the signifiers of the device, and then adds more features that way. But the key point here is really in the fact that these features usually are not as groundbreaking and as productivity boosting as the original feature, which was the reason for the device or the software or the service to be there.
Thank you, sir.
Yeah, sure.
This content was provided by RWTH Aachen University.